A space probe, unlike an ordinary Earth satellite, seeks out knowledge in regions far away from the Earth. As shown here in this historic film of the first probe, American Pioneer 1 was launched in 1958. First, it was placed in orbit about the Earth. Then another rocket was fired. The speed of the payload was to be boosted to 25,000 miles per hour, the speed necessary for an object to become free of the gravity of the Earth. No longer an Earth satellite, the space probe would then be free to coast to its far-off destination and radio back its findings by telemetry, the technique of transmitting or reading instrument recordings from a distance. Batteries are used to power instruments which detect and analyze various phenomena, and to power radios whose antennas send the findings back to Earth. This is how a space probe operates to bring us new knowledge. Pioneer 1, however, failed to escape the Earth's gravity and fell back, burning as it re-entered the Earth's atmosphere. In 1959, Russian Lunik 1 and then American Pioneer 4 were sent into space and beyond the moon. Lunik 2 revealed that the moon had no magnetic field. The discovery was made just before the probe hit the lunar surface. Lunik 3 was so engineered that it curved behind the moon and took photographs of the side that had always remained hidden from the Earth. Pioneer 5 was the first interplanetary probe. It was aimed at Venus and launched in the year 1960. In 1961, a Venus probe was launched by Russia. Both probes failed to get information about Venus. Both went into orbit about the Sun. But a new era had begun. Larger, more powerful rockets allowed larger, more sophisticated payloads. So man took his first step. First the Russians, then Americans, successfully orbited the Earth in the early 1960s. The next step will involve sending crews into space. The problems solved by such a project will undoubtedly lead to landing the first men on the moon. The second generation of moon probes, such as this Ranger, have helped to prepare for such a landing by collecting and relaying back information, by televising back to Earth details of the moon's surface. The same telemetry methods will be used for the more sophisticated moon probes, such as surveyors, designed to make an even more detailed study of the moon. Equipped with an elaborate system of solar cells, the surveyor will turn sunlight into electricity to power its instruments and radio. Because this side of the moon always faces the Earth appears suspended in the moon's sky and can always be seen because there is no atmosphere, clouds, or haze on the moon. Delicate instruments, whose measurements can be affected by even the presence of the spacecraft, are held away from the craft by long, mechanically operated arms. Mirrors reflect into the lenses of the television cameras a close look at the harsh, irregular surface which, except for meteorite impacts, is believed to have remained the same for millions of years. Meanwhile, other probes are being planned. Some will study the moon as they orbit around it. Some will explore the solar system, shown here by concentric circles representing the paths of some of the planets as they orbit about the Sun. Nearest the Sun is Mercury. Venus is next, then the Earth, then Mars. Because Venus and Mars come closer to the Earth than the other planets, the first probes have been in their direction. There are times when Venus is only 25 million miles away. However, at other times, it can be as much as 162 million miles away. Mars, our next nearest neighbor, is sometimes as close as 35 million miles away, but when the Earth and Mars are on opposite sides of the Sun, the distance is sometimes as great as 248 million miles. As a result of these variations in distance, space probes are launched only during those periods when the target planet is in a favorable position. Between 1965 and 1975, only certain years are favorable for probing Venus and certain years for Mars. Specially designed for interplanetary travel, the Mariner is capable of traveling great distances and sending back information gathered along the way. Shortly after launching, solar paddles unfold like butterflies' wings. Sensors cause the paddles to face the Sun. Solar cells are used to convert sunlight into electric power needed for telemetry. Through the nearly perfect vacuum of outer space, telemetry has already successfully functioned over a distance of 54 million miles. Radiation counters aboard the probes have revealed that the Sun constantly radiates streams of electrically charged particles called the solar wind, as symbolized here. During a solar flare-up, the radiation increases. How does this affect the Earth? Well, the Earth, like a bar magnet, is surrounded by lines of magnetic force, shaped something like this. Space probes have proved that the Earth's magnetic field controls the paths of the charged particles from the Sun, trapping and forcing them to circulate within the field. Some escape to form the Earth's aurora borealis. Some escape back into space. But the dense accumulation that remains is called the magnetosphere, and is symbolized here by this model. The magnetosphere is now known to be very dangerous to space travelers. Space probes have also discovered new facts about the planet Venus. A surface temperature of 800 degrees Fahrenheit, which would prevent life such as exists on Earth. Venus, like the Moon, rotates very slowly. Probes have found no magnetic field. But because there is a strong magnetic field around the fast-spinning Earth, many scientists now conclude that a magnetic field is caused when a celestial body rotates rapidly. Future probes will undoubtedly provide the answer. Space probes are mechanical scouts reconnoitering man's new frontier. Already they have warned him of the magnetosphere and its deadly radiation, of the searing death that lurks beneath the clouds of Venus.
13, 12,
As the Earthling learns to become a spaceman, he must ask himself many questions. Can I survive out there? What will I learn? What contribution can I make with this new knowledge?